Welcome you all for the wireless communication lecture module. In this lecture, we are going to discuss about the OQPSK, that is called the offset QPSK. So before going to the offset QPSK, first we will discuss about the conventional QPSK and what is the drawback of conventional QPSK, and then we will enter into the offset QPSK. So normally, the QPSK has a better advantage than the BPSK. Okay, so normally the BPSK can able to transmit one bit per symbol. Okay, in case of QPSK, with the help of two BPSK, it can able to transmit 2 bits per symbol. So the carrier is more number of bits can able to transmit with the help of a QPSK, and it is a more efficient than the BPSK. So this is the concept of BPSK. So normally, so look at the conventional diagram for the QPSK. This is the first one. Okay, so if you want to try and shift the bits from either 1 to 0 or 0 to 1. Okay, so if you want to transit two bits simultaneously, if you want to transmit two bits simultaneously, obviously that there will be a phase shift of a 180-degree in case of a QPSK. Normally, if you want to transmit one bit from 0 to 1 or 0 to 1 in BPSK itself, 180-degree phase shift. In normal conventional QPSK, if you want transient one bit, that has the 90-degree phase shift. If you want to transit two bits simultaneously from 0 to 1 or 1 to 0, obviously it will have a 180-degree phase shift. Okay, so if you want to change from 180-degree phase shift, the normal, the 180-degree phase shift will crosses the zeroth line. If the 180-degree phase shift crosses the zeroth line, obviously that will create a non-linear effect. Okay, in that nonlinear effects creates a side lobe level at the transmitter end. This is the drawback of QPSK. So if you want to transit two bits simultaneously, 1 to 0 and 0 to 1, okay, obviously the QPSK will have a 180-degree phase shift. That 180-degree phase shift will crosses the zeroth line. Whenever it crosses the zeroth line, it creates a non-linear effect. This non-linear effect will creates a side lobe at the transmitter side. The one more drawback of the conventional QPSK is the linear amplifiers could not amplify the required level of signal at the transmitter side. Okay, so these two are the drawbacks of a conventional QPSK. So the phase shift has to be reduced from 180-degree to 90-degree or less than that. So to reduce the phase shift, we are going for the different versions of QPSK, that is called as OQPSK, offset QPSK, and the second concept is pi by 4 QPSK. In this lecture, we are going to concentrate on offset QPSK. So here the offset QPSK, the normal data is first divided into even bits, odd bits. There is a in phase component and a quadrature phase component. So the initial data has to be divided into in phase component as well as a quadrature phase component. Here we are going to keep the in phase component as it is, and we are going to introduce some delay. Okay, in the quadrature phase component. Look at the diagram here. The in phase component will start at the point minus TB. Okay, so at 0, but the quadrature phase component, we are providing this some delay. After some delay, the signal will start. So that delay will reduce us the phase shift from 180-degree to 90-degree between these two signals. Everywhere listen. So if we are looking at the signal M0 and M1, we are, because of the delay, these two signals will have a 90-degree phase shift. Here it provides the 90-degree phase shift. So to compensate the nonlinear effect, we must reduce the 180-degree phase shift to 90-degree phase shift. To reduce the 90-degree phase shift, we are creating a delay in the quadrature phase component. We are delaying, deliberately delaying, that delay is called as a offset. Okay, because of this only, this system is called as a offset QPSK system. Okay, so it reduces the non-linear effect because of the reduction in the phase shift. So this has the higher advantage than the conventional QPSK. Okay, so here now, if you want to change from 2 bits, changing the 2 bits, it provides only a 90-degree jump instead of a 180 degrees jump. Okay, the fluctuation remains only 90 degree, not the 180 degree in the in phase as well as quadrature phase component. Okay, so with this, we'll close the offset QPSK. Okay, so normal conventional QPSK has some advantage than the BPSK, but the conventional QPSK has a 180-degree phase shift which crosses zero crossing line, produces non-linear effect. To overcome the non-linear effect, we have a different versions of QPSK, offset and pi by 4 QPSK. Out of which, in offset QPSK, we are deliberately delaying the quadrature phase component for some period of time. That delay is called as a offset. So this is about a offset QPSK.